Welcome to the Equations of Parallel and Perpendicular Lines, Podcast 2. This is writing equations in slope-intercept form. So there are several forms that the equation of a line can take. They may look different, but they all describe the same line. All linear equations describing a particular line are equivalent. So when maybe in Algebra 1 you talked about coinciding lines, it really is just two equations for the very same line. It really isn't two lines. Okay? They have everything in common. Okay? So there are different ways that we could write the equation of a line, and one of those is slope-intercept form. Right? So slope-intercept form of a line, y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line, or the y-coordinate of the point at which the line crosses the x-axis. The y-axis, excuse me. The y-intercept is the value of y when x is 0. Okay? So from a graph, we can just look where x is 0, and it's going to be 0 all along the y-axis. And so whatever point our line crosses the y-axis, that's our y-intercept. From an equation, we can find our y-intercept simply by plugging in 0 for x and solving for y. All right, so slope-intercept form, if the graph of an equation intersects the y-axis at the point 0b, then the number b is the y-intercept of the graph. All right, so in slope-intercept form, our y is going to be isolated. Right? That coefficient in front of x is going to be our slope, and that constant added in is going to be our y-intercept. I'd like you to add in the parts that I've written in on the smartboard up here. All right, so just add that to your notes. In your notes, it's about halfway down the first page. All right, so you've got yours looks identical to mine when I'm about there. All right, so just add that part to your notes. Right? We're just picking up from where we left off in the last podcast, which was slope. All right, so slope-intercept form of a line, y equals mx plus b. When a number is written when an equation is written in this form, where m is equal to any number, including 1 understood, and b is any number, including 0, we learn two things. We're going to learn the slope of the line and the y-intercept. Okay? So m is going to be our slope. It's that coefficient right in front of x. And b is going to be the y-intercept. It's where the line crosses the y-axis. Okay? And it's that number that's added in. Okay? All right, so we have some equations here. All right, we're going to do these together. You be thinking of the answer, okay, and while I write them up here. All right, so the first thing we'll do is we'll find the slope. Our first equation is y equals 2x plus 3. Right? That coefficient there that's right in front of x, that's our slope. So our slope is 2. Our y-intercept is this value that's added in here at the end. That's 3. We usually write that as a point. Right? But I have in the column right in between there, points on the graph of the equation. So that y-intercept 3 is really the point 0, 3. And you can see if I plug in 0 for x, I'd have 2 times 0, that's 0, plus 3, that's 3. So 0, 3 is our y-intercept. Right? We just don't have to plug anything in to actually find it because we have it in slope-intercept form. But if we plugged in x, we plug in 0 for x, you could find the y-intercept as well. Right? So I'll just put it over here. So y equals 2 times 0 plus 3. We could see it's 3. But we really didn't need to do that, right? Because we know that 3 is the y-intercept. Let's find another point on our graph. And we're given an x value of 1. Now we'll plug it in. So y equals 2 times 1 plus 3. 2 times 1 is 2 plus 3 is going to be 5. Right? I'll put it over here. Otherwise, I'm probably going to run out of space. Right, so 1, 5 is another point on the graph. Right, so the y-intercept is really easy to find when it's a slope-intercept form. We don't have to do any work at all. But to find other points, we're going to have to plug in the x value. Our second equation is y equals negative x plus 2. Okay. We don't normally write in 1. Okay, so if I want to say the slope is 1, right, because I don't bother to write it in. It's understood if there's no coefficient that our slope is 1. Because 1 times anything is still that same thing. So do I really need to write 1 times x? No, that's x. But we understand our slope is 1. Well, if I have a negative, same idea applies. Our slope is going to be negative 1 because we just don't bother to write in the 1. right? So our slope is -1 right there. Our y-intercept is that point 2. 0, and we know it's really the point 0, 2. So the value is 2 for the y-intercept, and it's the point 0, 2. To find the value of our function when x is 1, we will just plug in, oops, I'm writing the same equation again. We'll just plug in 1 for x. So we have -1 plus 2. Well, that's just going to be 1. Right? So 1, 1 is a point on our graph. Let's find another point, right? And deal with another equation. Right? So y equals 1/2 x minus 4. The slope is that coefficient in front of x, so our slope is 1/2. Our y-intercept is the value added in. It's -4. Don't forget that minus goes with that number. It's a -4. So the point 0, -4 is our y-intercept. And y equals 1/2 times 1 minus 4 is going to be a point on the graph. Now that's going to give me 1/2. And then I've got minus, well, I need to add those together. 4 is the same as 8/2, right? Because 2 goes into 8 4 times, right? So 8 divided by 2 is 4, so 8/2 is -4. So 1/2 minus 8/2 is going to give us -7/2. Okay? Get used to working with fractions. They are sometimes, when we try and divide fractions and make them decimals, we get non-terminating decimals, which means that our answers aren't going to be exact. They're going to be approximations. And we don't want approximations. We want exact. Now, it wasn't very hard, right, to subtract 8/2 from 1/2. All right, so let's look at the next one here. We have the equation y equals -2x. Right? Our slope is that coefficient that's right in front of x. It's a -2. Our y-intercept, we don't see any value added in, so that means our y-intercept is 0, and that means 0, 0 is the point. Okay? I'm kind of running out of space on this side, so I'm going to work over here, which is really stretching my microphone. Right? So we want to find the value of y when x is 1. So we have y equals -2 times 1. That's just going to be the point -2. Right? So 1, -2 is a point on our graph. And then our last one here, it is and it isn't the trickiest one. Right? So we want to find our slope, first of all. Well, what could it be? Is it 7? Well, it's not 7. What could it be? Well, I'm going to write this equation another way. What if I wrote it as y equals 0x plus 7? Is that the same as y equals 7? Well, 0 times anything is just 0, and 7 plus 0 is just 7. So y equals 7 and y equals 0x plus 7 are the exact same things. Our slope here is 0. Our y-intercept is 7. That means our graph goes through the point 0, 7. And if I plug in, hey, where do I plug in 1 for x? There's no x. Well, guess what? What do you think the y value might be? If y is 7, that means no matter what x is, y is 7, right? So there we go. We have all this filled in, right? Were there any of these that stumped you? Let me know in class if there were any that you had trouble with, if any of these you want to go over, all right? Or did you get them all correct, right? I think maybe the trickiest one is that last one, because you might not have thought of 0 as the slope. All right, so let's continue on. So you have this in your notes. It's just a little bit written a little bit smaller. It's on the left-hand side there. Writing an equation of a line from a graph. So it's on the left-hand side. It's just below where we were writing. Okay, so it's all the stuff on the left-hand side. All right, so you got to pick 2 points on the line and use them to find the slope. This is the value of m in the equation. Now sometimes you can count the rise and run. The points are easy to see. The lines on the graph are easy to see. It's nice and big. It's easy. Fine, you can count the slope. Sometimes, though, you might have trouble counting the slope. If you're having any trouble counting the slope, always use the slope formula. Okay? All right, and then we want to find the coordinates of the y-intercept. This should be in the form 0b. the y-coordinate is the value of b in the equation. Okay, so our y-intercept is a point, right? And it's that y value when x is 0, that's going to be our y-intercept. And all we have to do is substitute those numerical values for m and for b. And m is your slope and b is your y-intercept where it crosses the graph. Okay? So let's do a problem together. All right, so we want to determine the slope and x and y intercepts from our graph. All right, so here our slope is our rise over our run. Okay, I will calculate it out two different ways. Okay, I'm going to calculate it out with the slope slope formula, and I'm going to count it out. All right, so I'm going to do both. Okay, so if I were to use points on our graph, okay, perhaps I use the point. Well, here I have a nice point. I have the point 0, 3. It's the y-intercept. Okay, that's where our graph crosses the y-axis. So by the way, generally your y-intercept is pretty easy to find on the graph. So long as it's an integer value, it's pretty easy to find. Right? Our x-intercept is also pretty easy to find on the graph, particularly if it's an intercept. If it's an integer. All right? So there I can see that my graph is crossing the point negative 9, 0. That's our x-intercept. Oops, I'm sorry, I wrote down the y-intercept in the wrong spot. Because I was talking about the y-intercept on the last page, so I just kept talking about the y-intercept, but I accidentally wrote it next to the x-intercept. Our x-intercept is the point negative 9, 0. So notice that y is 0 for the x-intercept, and x is 0 for the y-intercept. Okay? All right, so now we have our 2 points. I could use that x-intercept and y-intercept to calculate out my slope. If I use those points, right, it's going to be the difference in the y-coordinates minus the difference in the x-coordinates. I'm just going to go top to bottom. All right, so this would be then 0 minus 3 and negative 9 minus 0. So 0 minus 3 is negative 3. And negative 9 minus 0, that's negative 9. Those negatives cancel. That number also reduces. Right? So 3 goes into 3. And I'm going to write it down. I'll write it down here as well once we calculate it from the graph. When I say down here, I meant over here. So we have negative 3 divides into, so 3 divides into negative 3 one time, right? Those negatives cancel. And 3 divides evenly into 9 3 times. So 3/9 is the same as 1/3 is what I'm getting at there. All right, so we could use the slope formula. In your notes, I'd like you to write that down. Also write down the x and y intercepts. We could also use the graph because it's really not too difficult to figure out our slope here. Right? And I can use any 2 points. Right? If I were to use the y and the x intercepts, right, I would still get the same slope as if I used the y-intercept and this other point right here on the graph. Either way, I can see that my line is going up 1, so up 1 vertically. For every 3, it goes to the right horizontally. Right? So if my line is going up left to right, it's going to be a positive slope. Right? So our rise here is 1, our run is 3, and that's the slope of our line. So with a line like this, with a graph like this, you could either calculate it using the slope formula, or you can just count the rise and the run. Okay? Just remember, we read a line from left to right. Count up or down first, and then count over. If you count up, it's positive. And when I say over, I'm going to be more specific. And then count right. All right, so if you count up, then it's positive. If you have to count down, then it's negative. But go left to right. And so now all we need to do is write the equation of our line, because I think we are writing the equation of a line. Right? So let's write to the equation of the line. I don't think I have a space for it on the next page. I just want to double check. No, we got a new line here. All right, so let's write the equation of our line. Y equals mx plus b. We can just substitute 1/3 for the x and 3 for our y-intercept. So there's the equation of our line. Okay? That wasn't too difficult, now was it? I'm going to do one more. This one is not in your notes. Remember, if you need more time, just pause the tape. All right, and I'm going to just calculate out the slope here from the graph itself. Right? You know, my x and y intercepts are really good points to use. Right? They're nice and clear. I can find them. Right? My x-intercept is where we cross the x-axis, right there, and this point right there is our x-intercept, and that's the point -2, 0. Our y-intercept is where we cross the y-axis. It's right up here, and that's the point 0, 3. So I could use those 2 points in the slope formula, or I could just use my graph to count it, right? So I notice I am, but I read left to right, my line is going up 3, so that's going to be positive, and then it's going to the right 2. That means my slope is 3/2. And that means the equation of my line, right, y equals mx plus b, is just going to be y equals 3/2 x plus 3, right, because we use the y-intercept. Right? And that's all there is to that. Right? In class, I have one more. We'll do one more together, and then when we're in class, we'll do the whiteboard practice. All right, so let's find this one. All right, let's find our I'm going to find the y-intercept. Now this one's actually a little bit different because notice my x-intercept, not so easy to find. Right? So we're going to want to use not our x-intercept but a point. And you know what? I think I'm going to save this one problem for class. So in class, we're going to do this problem together, and then we'll do the whiteboard practice. All right? So see you in class. Hope you enjoyed the podcast. Bye.